Hello, today we will be covering Passage 5 in the Science section of the first practice test for the official ACT Prep Guide. What I like to do for the Science sections is to just skim over the passage first and then look at the questions to see what parts we need to read in more detail. So I'll just go over the passage here, and please pause the video and read at your own pace. Alright, it is kind of a large passage for this set of questions, but let's see what the questions are asking. I won't go into too much detail about what the passage says before we get to the actual questions, because you only need to read exactly what you need to accurately answer the questions. So let's look at the first question, question 28. It says, studies 1 and 2 differed in which of the following ways? In study 1, the students determined how the spot's location varied with, and then we have 4 options here. Let's see, the options are, in study 1, the students determined how the spot's location varied with electric potential, plate length, the magnitude and direction of the electric field, and again, plate length. And then they differentiate each of the answers again by looking at how study 2 is varied. Okay, so let's start by going to study 1 and seeing what the students varied. So we can just go down to the definition for study 1. The students obtained a CRT having a certain length. They set V to a certain kilovolt, and they varied both the direction and the magnitude in some units. And we can see that here, alright, the direction is the same and then it changes, and the magnitude changes. Alright, so they varied indeed the direction and the magnitude. We'll go back to the question and see what answers are relevant. Okay, they varied electric potential, not that. Plate length, not that. The magnitude and direction, they did vary that, and therefore answer H is the correct answer. Note that we didn't even need to look at what study 2 did, because study 1 alone was able to differentiate the correct answer. So once again, try to save as much time as possible by reading just exactly what you need to answer this specific question. Next up, we have question 29, which reads, suppose that students had performed a trial in study 2 in which y was 2.6 centimeters. The value of v in this trial would most likely have been, then we have a few options here ranging from less than 1 kilovolt to greater than 2 kilovolts. Let's scroll up to study 2 and see what they did there. Okay, so they set E to a certain amount and varied V, and looked at the resulting values of Y. So we see V in kilovolts here starts at 0.5 and goes up to 2.5, and then Y in centimeters starts at 6.3 and goes down to 1.3. So it seems that as we increase the kilovolts, Y in centimeters decreases. Let's go back down to the question and see what they're asking for specifically. In study 2, we're looking for where Y would have been 2.6 centimeters. So although we don't have a point right at 2.6 centimeters, we see that there are two right around there. We have 3.2 centimeters and 2.1 centimeters. And because the trends are very nice here, as we increase V, Y always decreases. We can kind of make an educated guess about where we would find 2.6 centimeters for Y, probably in between 2.1 and 3.2 centimeters, or in between 1.5 and 1 kilovolts for V. So let's scroll back down to the available answers. And we see that, alright, A is less than 1. B is right in that sweet spot that we talked about, where it's between 1 kilovolt and 1.5 kilovolts. So B is the correct answer in this case. Question 30 says, Figure 2 could serve as an illustration of the results of which trials? Okay, so let's go over to Figure 2 here. This is what we're dealing with. And we see that there's a bright spot, and it's a positive number. It goes from 0 to 10 here. It's not in the negative range. And we can kind of count here 1, 2, 3 centimeters up. So it looks like the bright spot in Figure 2 is just about 3 centimeters up. So let's try to figure out which trials are relevant for us. If there are just 1, like F and G here, or if there are 2, like H and J show. So let's scroll down here to trial 1, and I'll clear this off right here. Okay, trial 1 has direction up, doesn't matter, magnitude doesn't matter, Y is negative 3.2 centimeters. Well, that's not right here. So we know it's not F, so we can just cross off F. And let's see what 4 is about, because that's the other one mentioned here in the options H and J. Trial 4, it's down, and it's positive right around 3 centimeters, just like we found up here. So it may be H or J. And you know what? We know it's not G, because it looks like 4 really could be Figure 2. So let's cross off G as well, which says 8 only, because it seems like 4 is is definitely possibly with figure 2. So let's clear this right here and scroll back on up and see what trial 8 is all about. So trial 8 here. Alright, it has a y of 3.2 centimeters, which agrees with trial 4 as well. So it looks like both trials 4 and 8 were right around that same range that we saw in figure 2 of around 3 centimeters. So let's scroll on down, and this allows us to select the correct answer in this case, which is J, trials 4 and 8. Question 31 says, based on the results of study 1, in which direction did E most likely point in study 2, and in which direction did E most likely point in study 3? Alright, so we're going to have to look at study 1 here to figure out what probably happened in study 2 and study 3. So the direction of E is what's important here. So let's go over to study 1 and we see table 1, alright, E, direction. And we have up, 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 down, down, down. And we look for any correlations here. The magnitude is something we set, so that doesn't really matter. And in Y, so the bright spot's location, we see that for each of the up, E directions, the results were negative, and for each of the down, the results were positive. So it seems like if Y is positive, then the direction for E is down, and if Y is negative, then the direction for E is up. So let's go look at studies 2 and 3 to see what they have here. All of the results for study 2 had Y being positive. Okay, and let's scroll back down. We're doing a little bit of scrolling here. And that corresponds to a downward direction for E. So let's look at our options here. That gets rid of options A and B because those have an upward directions for study 2. Now we have two options here with downward for study 2, and we have up and down for study 3 for C and D. So we need to go up to study 3 and see that, alright, all the Y's here were negative. And so that suggests, scrolling back to study 1, that the direction for study 3 was up. So remembering that we have for study 2, the correct direction is down. For study 3, the correct direction is up. We get the correct answer of C. Alright, our next question, question 32, says, once a CRT is sealed, it cannot be reopened. However, because both V and E are controlled from the outside, a CRT can be used repeatedly under varying conditions. Based on the descriptions of studies 1 through 3, what is the minimum number of different CRTs that the students required to complete the 3 studies? Again, we have options 1, 5, 11, and 16 here. So for all 3 studies, we're looking for the minimum number of different CRTs. The ACT doesn't want you to fail, and so they're not going to hide any information. In fact, they're going to italicize the important parts here, like the word minimum. So we're looking for the exact minimum of the number of CRTs that were needed for all of these studies. So let's scroll on up and kind of look at this here. This is a tricky question because there are some subtleties. There were 16 total trials, but they could have reused some of the CRTs for the different parts of the studies. So let's see. V and E are controlled from the outside. Okay, here we're controlling E, changing E in its direction, and they're keeping V set to a constant. And so you only need one CRT for study 1. If we scroll on up to study 2, it says using the CRT from study 1, and then they change V. So far for studies 1 and 2, they only needed one CRT. Going on to study 3, the students obtained various CRTs. Okay, this is a hint that we need more than one CRT. It says each having a different L. For each CRT, they set V and then the E, and they varied L. So it looks like for each CRT, because you cannot vary L once the CRT is constructed, they needed 1, 2, 3, 4, 5 different CRTs for study 3. Now, however, maybe one of the CRTs from study 3 could have been used in studies 1 and 2. Scrolling down, we see that the CRT in study 1 had a length of 2.5 centimeters for L. We scroll on up to the CRTs in study 3 and we see that, yes, 2.5 centimeters was one of the L's used in study 3. So they only needed 1, 2, 3, 4, 5 CRTs total, and they could be used for all 3 studies. We scroll on down and it looks like G is the correct answer here with 5 CRTs. Question 33 asks, suppose that the students had performed a trial in which the cathode rays traveled all the way from the filament to the screen in a straight line path, striking the screen at y equals 0 centimeters. Based on the results of studies 1 and 2, which of the following statements about V and the magnitude of E in this trial would have been true? Alright, so we're looking for info about V and E. when the straight line path of the cathode ray would strike the screen at y equals 0 centimeters. So let's scroll on up and look at studies 1 and 2. Okay, in study 1 we varied E, its magnitude and its direction, and we see that the resulting striking distance was between negative 9.5 and 9.5, and it looks like if E was around 0, then we would have y equals 0 centimeters. So that's kind of promising. It looks like we need E to be 0 based on study 1 to get y equals 0 centimeters for the bright spot. But let's scroll up to study 2 and see if we can learn anything else. It appears like V here, when it's smaller, y is larger, and as it gets bigger, y gets smaller, but it doesn't look like it approaches 0. It doesn't seem to be a simple relation like that. So let's scroll on down and see if we can figure out a correct answer here. So based on the results of studies 1 and 2, about V and the magnitude of E. From study 1, it looks like E needs to be 0, and from study 2, it looks like nothing special about V needs to hold true if we want y to equal 0. So let's look at our options here. V was 0, but the magnitude of E was non-zero. Well, that's the opposite of what we want. B says V was non-zero, but the magnitude of E was 0. That looks exactly like what we want, so we can stop reading here and select B as the correct answer. Alright, our last question is question 34. It says, in a CRT, E is generated by building up equal and opposite charges on the two conducting plates. Suppose that cathode rays are negatively charged. If E is directed downward, as shown in figure 1, which conducting plate is more likely the negatively charged plate? Okay, so we're going to have to look at figure 1 here, and we're also going to have to know some things about electric charges and how they behave. So let's scroll on up to figure 1 and take a look at it. Okay, E is pointing downward, and the cathode ray appears to go up after going through the electric field that is pointing downward. Let's scroll back down and revisit the question here. And it's asking, which conducting plate is more likely the negatively charged plate? Okay, so it's asking for which plate is the negatively charged one, and we're also supposing that cathode rays are negatively charged themselves. So in this question, we actually require outside knowledge about electric charges. This isn't shared in the passage, but we know that likes charges, or like magnetism, repel each other, and opposites attract. So we need to scroll back up and look. We have a cathode ray, and it shoots through here, and the electric field is pointing downward. And instead of going down with it, it starts to go up. And we have one plate here and one plate here, and they're oppositely charged. And so if this cathode ray is negatively charged, and it wants to go away from this bottom plate, then this bottom plate must be negatively charged, and this upper plate is positively charged. Since opposites attract, and if the upper plate is positive, then it would attract the cathode ray, and the bottom plate would repel the cathode ray. So we'll scroll down and look for the correct answer here. Which one is the negatively charged plate? We know it's the bottom plate, so it's not F, it's not G, it's either H or J. Let's read the options for H. Because charges of like sign are attracted to each other, that's not correct, and we know that the correct answer is J, because charges of like sign are repelled from each other. Alright, let's recap what we covered in this passage. Only the last question required outside knowledge not presented in the passage. We had to have some knowledge about how electric charges behave. Going backwards, we know that the ACT likes to highlight the important parts of questions, like the word minimum here. They don't want you to mess up. Although this reading section was actually kind of long because there are 3 different studies and they each presented different information, each question only involved a small portion of it. So I want to reiterate that it's often beneficial to simply skim over the passage and go straight to the questions to see which parts you need to read in more detail. Thank you for watching, and I hope this helped.